Welcome back to NextTed by Nexaspaces. In today's Module 5 lesson, we're diving into the communication backbone of IoT, wireless protocols that connect your smart devices. Wi-Fi, Bluetooth, Zigbee, and LoRa, you've heard these names, but do you know when and why to use each? Let's break them down, one by one. In the vast universe of the Internet of Things, communication is key. Imagine hundreds or even thousands of devices, sensors, actuators, gateways, controllers, all scattered across a factory floor, a farm, a city, or even inside a smart home. They all need to exchange information, either with each other or with a cloud server. But here's the challenge: not every device needs high-speed communication, and not every device can afford to consume a lot of power. That's where communication protocols come in. A communication protocol defines the rules and methods by which devices exchange data. It's like a language, different protocols are optimized for different purposes. Some are designed for short-range, high-speed data transfer. Others are optimized for long-range, low-power communication. Some protocols support mesh networks, where data hops from one device to another. Others use star topologies, where all nodes connect to a central hub. Choosing the right protocol impacts power efficiency, range, data throughput, reliability, scalability. So, in this video, we'll focus on 4 major communication protocols that dominate IoT systems: Wi-Fi, Bluetooth, Zigbee, and LoRa. Each one has its strengths, weaknesses, and ideal use cases. Let's begin with Wi-Fi, the most common protocol you use every day. Wi-Fi operates in the 2.4 GHz and 5 GHz frequency bands, delivering high data rates that can reach up to several hundred megabits per second, even gigabits with modern standards like Wi-Fi 6. It's perfect for applications that demand real-time streaming, large data transfers, or continuous cloud syncing, like smart surveillance cameras, voice assistants, laptops and tablets in smart environments. But Wi-Fi isn't perfect for all IoT. Why? Because it's power-hungry. Devices need to stay constantly connected to maintain speed, which drains batteries quickly. Also, its range is relatively limited, typically around 30 to 50 meters indoors. So, while Wi-Fi is ideal for mains-powered devices, it's not recommended for small, battery-powered sensors that only need to send tiny packets of data occasionally. Key features of Wi-Fi: frequency, 2.4 GHz and 5 GHz. Range, 30-50 meters indoors. Data rate, up to gigabit speeds. Power use, high. Topology, star. Now let's explore Bluetooth, especially Bluetooth Low Energy, or BLE. Bluetooth is designed for short-range, low-power communication between devices. You've used it with your wireless headphones, smartwatches, fitness bands, and Bluetooth speakers. In IoT, BLE has become a game-changer. BLE significantly reduces power consumption while maintaining enough bandwidth for most sensor and control applications. Its range? Typically 10 meters, though BLE 5.0 can go up to 100 meters under ideal conditions. The data rate is lower compared to Wi-Fi, around 1 to 2 megabits per second, but that's sufficient for many IoT tasks like transmitting temperature or heart rate data, unlocking doors via smartphones, synchronizing data between wearables and phones. Also, BLE supports mesh networking, allowing devices to relay data through each other, great for expanding range in indoor environments. Key features of Bluetooth: frequency, 2.4 GHz. Range, 10-100 meters, BLE 5. Data rate, 1 to 2 megabits per second. Power use, low. Topology, P2P/mesh. Next up, Zigbee, a protocol specially designed for home and building automation. Zigbee runs on the IEEE 802.15.4 standard, operating in the 2.4 GHz band. What sets it apart is its native support for mesh networking. That means each Zigbee device can act as a repeater, extending the network range and improving reliability. perfect for environments with lots of walls or devices. Its range per device is typically 10 to 100 meters, but with mesh topology, you can extend the total network across entire buildings. Zigbee consumes very little power, making it ideal for battery-operated devices like motion sensors, smart bulbs, smart plugs, window and door sensors. However, Zigbee often requires a dedicated hub or coordinator device that connects the Zigbee network to the internet. Key features of Zigbee: frequency, 2.4 GHz. Range, 10-100 meters per hop. Data rate, up to 250 kbps. Power use, very low. Topology, mesh. Requires a Zigbee coordinator, hub. Last but not least, we have LoRa, short for long range. LoRa is designed for ultra-long-range communication. We're talking up to 15 kilometers in rural areas and a few kilometers in cities. It operates in the sub-GHz bands like 433 MHz, 868 MHz, EU, or 915 MHz, US, which allows signals to travel farther and penetrate obstacles better. It's not fast, data rates are between 0.3 kbps and 50 kbps, but it's perfect for sensors that transmit small packets occasionally, like soil moisture sensors, GPS trackers, weather stations, industrial monitors. It's incredibly power efficient, allowing battery-powered devices to run for 5 to 10 years without replacement. LoRa is often used in combination with the LoRaWAN protocol, which manages message routing through gateways to a centralized network server. Key features of LoRa: frequency, sub-GHz, 433/868/915 MHz. Range, 2 to 15 kilometers. Data rate, 0.3 to 50 kbps. Power use, extremely low. Topology, star, via gateway. Ideal for low bandwidth, long-range IoT. Now that we've explored each protocol individually, let's bring them all together in a single, easy-to-understand comparison table. This table helps you visually compare key features of Wi-Fi, Bluetooth, BLE, Zigbee, and LoRa, and it will guide you in choosing the right one for your IoT project. Let's go row by row. 1. Frequency. First, the operating frequency. Wi-Fi works on 2.4 GHz and 5 GHz bands. Bluetooth, especially BLE, also uses 2.4 GHz. Zigbee uses 2.4 GHz as well, though in some regions it can also use sub-GHz. LoRa, on the other hand, operates in sub-GHz frequencies like 433 MHz, 868 MHz, or 915 MHz, depending on your region. Lower frequencies like those in LoRa have better penetration through walls and longer range, but typically carry less data. 2. Range. Next up is communication range. Wi-Fi has a practical indoor range of about 30 to 50 meters. Bluetooth ranges from 10 to 100 meters, depending on the version. BLE 5.0 extends this significantly. Zigbee offers 10 to 100 meters per node, but it supports mesh networking, allowing it to cover entire homes and buildings by relaying data across multiple devices. LoRa excels in range, anywhere from 2 to 15 kilometers, making it ideal for wide-area sensor networks. So, if your devices are far apart, think farms or citywide monitoring, LoRa is your go-to option. 3. Data rate. Let's talk about how fast each protocol transmits data, called data rate. Wi-Fi is the fastest among the four, supporting hundreds of megabits per second, ideal for high-bandwidth applications like video or file transfer. Bluetooth, BLE, offers 1 to 2 megabits per second, enough for sensors and audio streaming. Zigbee provides around 250 kilobits per second, which is perfect for transmitting sensor readings and control signals. LoRa, however, is designed for low data applications, with speeds between 0.3 kbps to 50 kbps. That's enough for temperature data or GPS location, but not for video or images. So, if speed is your top priority, Wi-Fi is best. But for low bandwidth use cases, LoRa and Zigbee are perfect. Now let's compare power consumption. Wi-Fi consumes a lot of power. That's fine for plugged-in devices, but not for battery-powered sensors. Bluetooth, especially BLE, is designed for low-energy operation. Zigbee goes even further, it's extremely power efficient, which is why it's used in devices that need to last months or even years on a coin cell battery. LoRa wins the game in ultra-low power. A properly configured LoRa sensor can run for 5 to 10 years on just a pair of AA batteries. So if your device needs to run for years without maintenance, Zigbee or LoRa are the best choices. Next is network topology, that means how devices connect to each other. Wi-Fi uses a star topology, where all devices connect to a central access point or router. Bluetooth can operate in point-to-point, broadcast, or mesh modes, depending on your use case. Zigbee is built around a mesh network, where every device can pass data along. This improves reliability and range. LoRa also uses a star topology, where multiple end devices send data to a central LoRaWAN gateway, which forwards it to a cloud server. If you need a network that's self-healing and scalable across rooms or floors, Zigbee's mesh design is highly effective. Finally, let's look at the ideal use cases for each protocol. Wi-Fi is best for applications that need high data rates, like smart cameras, streaming devices, or cloud-based dashboards. Bluetooth shines in wearables, fitness trackers, and smart locks, where proximity and low power are important. Zigbee is perfect for home automation, lights, sensors, and smart thermostats. LoRa is built for smart agriculture, citywide air quality sensors, GPS trackers, and remote monitoring, where range and battery life are far more critical than speed. Let's summarize this entire table in one sentence. Use Wi-Fi when you need speed and have access to power. Use Bluetooth when you need short-range, low-power links with smartphones. Use Zigbee for smart home devices that work together over a mesh. Use LoRa when you need to transmit small bits of data over very long distances with minimal power. Choosing the right protocol is all about balancing range, power, and data needs. Here's a quick cheat sheet. Use Wi-Fi when your device needs constant high-speed access and has access to power. Use Bluetooth Low Energy when your device is battery-operated and only needs to transfer small bits of data nearby. Choose Zigbee for smart home systems where devices form a dense mesh and need ultra-low power. Go with LoRa when your sensors are far apart and you need long-term battery life with low data traffic. There's no one-size-fits-all in IoT. The right protocol depends on your use case, environment, and energy budget. That wraps up our overview of wireless communication protocols in IoT. You've just taken a big step in understanding how smart devices talk to each other. In the next video, we'll show you how to set up Wi-Fi on the ESP32 board, a hands-on tutorial that brings these concepts to life. If you found this helpful, don't forget to like, share, and subscribe to Nexaspaces by Nexaspaces. And as always, stay curious, stay connected.